Hi, and welcome to Stoichiometry Clarified. Well, hopefully anyway. This is part 1. So if we were in class right now and I asked, does anyone have any questions about stoichiometry? This is likely the responses I would get. And my personal favorite, can I go to the bathroom, of course. So with that being said, we need to sort of tackle this and address some of the misconceptions about stoichiometry. Now, the reason why stoichiometry for many students is difficult is actually it involves two types of knowledge. The first type is conceptual understanding, and that involves reading comprehension and understanding the science behind the problem. The second type of knowledge that you need is problem-solving skills, and that involves identifying and analyzing key information in the problem, along with the mathematics needed to solve the problem. Now, most people's brains actually process these two types of information separately, and consequently, it's hard to learn them both at the same time when you're learning something new. If you've seen it before, then it's usually easier, but if it's the first time seeing something like this, it can make it difficult. However, it's important for stoichiometry problems that you have both pieces of knowledge for complete understanding. So what we're going to do is we're going to first focus on the conceptual understanding with a real-world application. And then we're going to break down the problem-solving process for these stoichiometry problems. So let's look at our real-world problem. Let's say you are an independent silver miner. And one day you find a piece of silver ore known as arginite that is made up of silver sulfide, Ag2S, that weighs 10,000 grams, which is about 22 pounds. Now, if the price of silver is 56 cents per gram, and assuming that the argentite is 100% silver sulfide, I want you to answer the following question. How much is the piece of silver ore weighing 10,000 grams worth? Now, to answer that question, you're going to need to know how much silver is in the 10,000 grams of silver sulfide. And to do this, essentially, what you need to do is to convert from 10,000 grams of silver sulfide to the mass of silver. And so therefore, this problem is a stoichiometry problem. And it's a stoichiometry problem because remember, in a stoichiometry problem, you're going to be converting from the amount of one substance to the amount of another or different substance using mole ratios. Now, you may be wondering, well, how exactly do I convert from the 10,000 grams of silver sulfide to mass of silver? And maybe one thought that comes into your head is this. Well, since one silver sulfide molecule contains 2 silver atoms and 1 sulfur atom, that means that 2/3 of the silver sulfide is silver. Therefore, the mass of silver in the silver sulfide would be about 2/3 the mass, right? So you may be thinking that kind of sounds logical. 2/3 of the 10,000 grams should be the mass of silver. Unfortunately, this does not work. And that's because you cannot convert directly from 10,000 grams of silver sulfide to the mass of silver. So let's talk about why that is. That's because the molar masses of silver and sulfur are not the same. Silver indeed is a lot heavier than sulfur, and therefore the 2 silver atoms in silver sulfide contribute more than 2/3 to the mass. And you can see that if you look at the average atomic masses in the periodic table for silver and sulfur. Silver is about 108 grams per mole, and sulfur is only 32 grams per mole. It's also evidenced by the mass percent. If you calculate the mass percent of silver in silver sulfide, it's 87%. That means that the silver in the silver sulfide contributes 87% of the mass. So 87% of the mass of the 10,000 grams will come from the silver. Now, of course, you could use the mass percent and then to answer the question. But we're doing this using our stoichiometry, our mole ratios. So let's talk about how do we convert in this and using stoichiometry from 10,000 grams of silver sulfide to the mass of silver. And to do that, we need to go through moles. So what does that process look like? Well, we're starting with 10,000 grams of silver sulfide, And then what we're going to do is we're going to convert that to the moles of silver sulfide. Once we have the moles of silver sulfide, now we can convert to the moles of silver. Because remember that if you have different substances and you want to convert between them, they have to both be in moles. So if you have the moles of silver sulfide, you can then go to the moles of silver. And then now we can determine the mass of silver. So why do we have to go through moles? Well, that's because the subscript in chemical formulas are actually mole ratios. So when we talk about a ratio tells you the relationship between two values. And in the case of the problem that we're looking at, we're focusing on the ratio of silver in silver sulfide molecule, sorry. So what if we had one molecule of silver sulfide? If we look at that molecule, we can easily see that there are two silver atoms. And so therefore, we can say in one silver sulfide molecule, there are two silver atoms. And we can express that ratio, that 1-to-2 ratio, as 1 mole of silver sulfide is equivalent to 2 silver atoms. Well, what if we were dealing with a dozen silver sulfide molecules? Well, as you see here, I have a dozen of them. And you could, if you wanted to, count up all the silver atoms. And if you did that, you would get 24, which corresponds to 2 dozen. And so that would make sense. If you have a dozen silver sulfide molecules, you should have 2 dozen atoms. And once again, our molar ratio could expressed as an equation would be 1 dozen silver sulfide molecules is equivalent to 2 dozen silver atoms. But chemists don't deal in amounts in terms of dozens or number of molecules. They deal with it in terms of moles, right? So what if we had a mole of silver sulfide molecules? Well, then if you were to count up all of the atoms, it's going to be double that number, right? So that would be 2 moles of silver atoms. So again, the mole ratio would be 1 mole of silver sulfide is equivalent to 2 moles of silver atoms. And it's that mole ratio that we use for these problems when we're trying to convert between different substances. So notice that you're going to get that information for the mole ratio from the subscript in the chemical formula. As you can see here from the chemical formula, there are 2 silvers in 1 silver sulfide molecule. So let's look at how we actually do this problem. Let's go through the process of solving this. So the first thing that we're going to do is we're going to convert from the 10,000 grams of silver sulfide to the moles of silver sulfide. And when we're converting from one amount of a substance to another amount of the same substance, we're still dealing with silver sulfide. That's when we use our mole map. So we look on our mole map and we're starting with mass and we're trying to get to moles. We have to go through the molar mass. So our work for that will look something like this. We take our given, put it over 1, and then in our conversion factor fraction, that's going to come from the molar mass. 1 mole of silver sulfide is equal to 247.81 grams. And remember, I put the grams on the bottoms so that the units of our given can cancel out. When I do my math, I get 40.35 moles of silver sulfide. So now that I have the moles of silver sulfide, I now can convert from moles of silver to moles of silver sulfide to moles of silver. And for this, we're going to use mole ratio. So it's 1 mole of silver sulfide is equivalent to 2 moles of silver. So this becomes my conversion factor. So I take my moles of silver sulfide, so that 40.35 moles, I put it over 1 just to make it into a fraction. And then the second fraction will come from the ratio, the molar ratio. So since I'm trying to get rid of moles of silver sulfide in that conversion factor fraction, I put the 1 mole of silver sulfide on the bottom. So this 1 mole, again, it comes from this this mole ratio or conversion factor. And then the 2 moles of silver go on top. All right, when I do that, I get this as my moles of silver, 80.71 moles. Now I can convert from moles of silver to the mass of silver. And in this case, now I'm going back to that mole map. So I'm starting with the moles of silver, trying to get to the mass. I need to go through the molar mass. And here's my work for that. So the molar mass for silver, it comes from the periodic table. And when I multiply that out, I get 8,706 grams of silver. So that means that in 10,000 grams of silver sulfide, there are 8,706 grams of silver. And at 56 cents per gram, the 10,000 gram silver ore is worth $4,875.36. Now that's a lot of change. All right, so as you saw in this problem, we did the steps of converting from 10,000 grams of silver sulfide to the mass of silver in a stepwise process. We did each problem or each part of the conversion in separate steps. You can also do this as one line of work. And in fact, that's how we did it in the Unit 7 Day 2 worksheet examples. So let's go through this line of work. So instead of doing these 3 steps, we can write it all out like this. So the first 2 fractions that I'm multiplying is actually used to convert from my 10,000 grams to my moles of silver sulfide. And you can see that if you look at step 1, if you go back to step 1, these first 2 fractions are the same first 2 fractions used in the first step of this problem. Now the next fraction is the conversion factor that I used in step 2. And I did that to go from moles of silver sulfide to my moles of silver. And then this last fraction here, that came from step 3, the conversion factor in step 3, where I used it to convert from moles of silver to mass of silver. So it's up to you how you want to do this. If you want to do this in step by step, or if you want to do it as one line. Now, doing it as one line of work really requires that you are confident and you know exactly what you're doing. So if you're not confident in this, which practice is really what needs to get to that point, then you might want to do it step by step. Either way works. So let's go ahead and summarize this process. So the first thing that you want to do in these stoichiometry problems is, of course, identify your given and find. But once you have your given and find, you want to convert your amount of given to moles of given using the mole map. Now, you only need to do this if the amount of your given is not in moles. If it's in moles, you can go ahead and skip this step. The second step is to convert from moles of given to moles of find. And for that, you would use mole ratios. Now, in all of the problems that you've seen here, the mole ratios come from the subscript of the chemical formula. Later on, we're going to see examples where the mole ratios are going to come from the coefficients in the balanced chemical equation. The last step is to convert from moles of find to the amount of find using our mole map once again. So remember, for this last step, you only need to do it if they're asking for if your find is not in moles. So if your find is in moles, you can go ahead and skip this step. All right, now last thing I want to mention to you guys is that your stoichiometry problem must have a mole-to-mole conversion. If it doesn't have a mole-to-mole conversion, it's not a stoichiometry problem. And indeed, remember that the only way you can convert from different substances is that they have to go through moles, and that's what a stoichiometry problem really is all about. So that central part right there, moles of given to moles of find, is what makes a problem a stoichiometry problem. If not, if you don't have that part, it's just a mole conversion or mole map problem. All right, so in part 2, what we're going to do is we're going to go over the example problems from the Unit 7 Day 2 worksheet. If you did part 1 and you feel like you understand it and you think you can go ahead and do that, you don't have to watch the part 2 video because we're just going to go over the same example problems, but we're going to do the math step by step. All right, that's it for this video. Hopefully it was helpful. Have a quality day.